All right, so say you have a triangle, and this triangle has sides 3, 4, and 5. Now, you could measure what these angles are, and so I've taken I've labeled these angles and measured them as 53.1 and 36.9, and so this is a real triangle. You could measure it, it would work. Mine might not be exactly to scale, but so the way trigonometry works is we're going to look at the ratios of the sides of this triangle. Now on this triangle there's nothing to be found, so we don't really need to look at anything further other than what we already have right here. But let's look at a similar triangle to this. And remember, similar means it's got congruent angles and it's got proportional sides. So let's say I look at a similar triangle to this one. I'm going to draw it a little bit bigger. And I'm going to label the angles the same, 53.1, 36.9. So let's say that I know that this side is 8. So already, before you even knew anything about trigonometry, you would be able to figure out what the sides that you don't have on this other triangle are. You know these are similar because they have congruent angles. And since they have congruent angles, you know they're similar, then they need to have proportional sides. So you could set up a proportion and say, oh, well, I must know that 4 over 8 is equal to 3 over this question mark, and that 4 times this question mark must equal 24, and that means that the question mark is equal to 6. So you would be able to figure out what this side is. This side is equal to 6. Now, in this case, these two triangles are proportional. If you look at the ratio between the sides, I'll do this in a different color. If you look at the ratio between the sides, this you've got 4 and 3, and then on this other one you've got 8 and 6. And so you'll see that 4 over 3 is equal to 8 over 6. And if you looked and tried to find out what this third side is, it comes out to 10. And so this 4 over 3, 8 over 6, we would be able to show that with the other sides as well. So if you wanted to look at, say, 5 over 3 and 10 over 6, those would reduce to the same thing. So the way trigonometry works is that we take this idea and we extend it to other triangles. So in this particular triangle, we know what the ratio between these two sides are, between these two sides, between these two sides. There are 3 possible combinations. If you're looking at this particular angle, then you can either look at the opposite and the adjacent side, you could look at the opposite side and the hypotenuse, or you could look at the adjacent side and the hypotenuse. And so I've got 3 different possibilities for how I could look at the ratios between these sides. So you might say to yourself, well, how could this help me find anything? So it turns out that people have put together tables. And so for a triangle that's a right triangle, this is very important, with an angle of 53.1, say, that the ratio between the opposite and the adjacent side is 4 over 3. And so there's a table somewhere that says for every triangle that's this size, that's going to be the ratio, because it works for this triangle and it works for this triangle. And so if we were going to make ourselves a little table, we could do that and say, okay, well, if you had an angle of 53.1, then you could look and say, oh, well, that means the opposite and the adjacent side are going to have one, the adjacent side and the hypotenuse are going to have one, and that the opposite side and the hypotenuse are going to have one. And we could look at what that table would be for this triangle. So if you've got a degree of 53.1, you know that the opposite over the adjacent side, if you look back at our triangle here, the opposite and the adjacent is 4 over 3. We know that the adjacent and the hypotenuse is going to be 3 over 5. And we know that the opposite in the hypotenuse is going to be 4 over 5. So you can fill out this table. These tables exist for other ones as well. So in the situation that we might want to use this, if we had a triangle that looked like this, and I knew that this was a right triangle and this was 53.1 over here, and say I knew that this side was 18, I don't know. Well, I know that the adjacent over the hypotenuse, which would be the adjacent side here, over the hypotenuse, should be 3 over 5. So I could say, okay, well, I should be able to take this and say, well, 3 over 5 is equal to my adjacent side over the hypotenuse, and then I could solve this and figure out what it is. Because I know my hypotenuse is 18. So this idea exists for all different types of triangles. If you look at this table here, we've got it for all different types of degrees. If you look at the degree 0, degree 1, 2, 3, 4, 5, we know, and these are names for what I'll show you in a second, but these ratios exist for the opposite side and the hypotenuse. That's what the sine is. This exists for the adjacent and the hypotenuse, which is what the cosine is, and it exists for the opposite over the adjacent, which is what the tangent is. So we've written down these values for all the different possibilities in a triangle. Now this table only has it 0, 1, 2, 3, 4, etc. But our triangle was 53.1, so there are tables that are even more detailed than this one. And so over time, we've been able to figure out how to write down all of these different ratios for these triangles. So trigonometry is really all about ratios. That's a big takeaway here. So trigonometry is about ratios of sides of right triangles. So we can use these ratios to figure out things about any kind of right triangle. As long as we know either an angle or a side, we can use it to solve for something in a triangle if we want to. And we can use our table to figure that out. Or we can use a calculator, and I'll be able to show you how that works as well. So let's just recap what our three different possibilities are for sides, and then we'll look at some examples. So for any right triangle, you need to be looking at an angle. So there's three different relationships which we wrote down up here. We had the opposite and the adjacent hypotenuse, the opposite and the adjacent. So our three different possibilities when you're looking at a particular angle, I've got my opposite, I've got my hypotenuse, and I've got my adjacent side here. So your three different possibilities that we label those: sine, we use for the opposite and the hypotenuse. We use cosine for the adjacent and the hypotenuse. And then we use what we call tangent for the opposite and the adjacent. And the opposite and the adjacent. So these are our three different trigonometric functions, we call them. And these will allow us to look at the opposite and the adjacent and the hypotenuse in all different types of triangles, and we can solve for missing sides that we might not know. Remember that in this table we had sine, cosine, and tangent. And so these are the names for the ratios of these particular sides. Cool, so recap. Trigonometry is all about similar triangles. They have to be right triangles. Remember, right triangles, similar triangles, and it's about the ratios of the sides of these right triangles. So the ones that we're going to be looking at, we've got sine, we've got cosine, and we've got tangent. And so these are the three biggies here, the three ones that we're going to look at.